these are the most common questions that are asked on section 3.3. So we're practicing our logarithm rules to simplify and rewrite logarithms. So the first up is log base 4 of 8. And when you see things like this, that 4 and 8 maybe have a similar base that you kind of have a hunch, or maybe you see they're both even, so maybe there's something going on there. Usually change of base is the thing to try. Before you do it, if you don't already know how to rewrite 4 as a power of 2 or know that it's base 2, same thing with 8, just try to do a factor tree and see what they break into. So we could rewrite 4 as 2 squared, 8 is 2 cubed, and that's a pretty good indication that change of base is a good way to go because they both are base 2. So we'll do log base 2 of 8 divided by log base 2 of 4. And I'm just going to rewrite, this is probably more than you need to do, but I'm just going to rewrite 8 as 2 cubed. If you're starting to think in logarithms better, you can skip some of these steps. But I'm just showing you everything. 4 is 2 squared. So log base 2 of 2, that basically goes away, and all you're left with is the exponent. Another way to look at it is the 3 comes out front. Log base 2 of 2 is 1, because 2 to the first is 2. So either way you go, you're left with just 3 on top and just 2 on the bottom, because you get those basically cancel out, if you want to say that. So 3 halves would be your final result, and no calculator needed to get that. On 41, you've got natural log of 5e to the 6th power. I like putting parentheses around things to kind of group it together. The book doesn't usually do that. Sometimes that leads to some confusion. So a lot of times when I explain it, I'll put parentheses around where they should have been so you kind of see what is grouped together. Now this is 5 times e to the 6th. Order of operations, I don't want to say they don't apply, but we kind of have a lot of freedom here. We can go different directions and still end up in the same spot. So the way I like to start this is it's 5 times e to the 6th. And I know that if a logarithm is made up of two things multiplied together, so I'll put a little multiplication dot there. Well, these things being multiplied means their exponents got added. And a logarithm is an exponent. So the logarithms are going to get added if these numbers got multiplied. So one more time. If these numbers multiply, their exponents add. Logarithms are exponents, therefore logarithms are what are being added together. So log, natural log of 5, plus natural log of this other term, e to the 6th power. That's where we end up now. And really, the only thing left to do is this 6 can come out front if you want to look at it that way. Or natural log is log base e, the e, and that all cancels out. 6 is all you're left with. So a couple ways to go there. But you get 6 on that part, and you get log of 5 here. And I'll put some parentheses around that. That's really all we can do because we can't take log of 5 easily without a calculator. That's going to be a pretty challenging thing to do. But to rewrite that as a 6 is way easier. And again, looking forward to calculus. This would involve a lot of work. This would be pretty much a 2-step problem, maybe even 3, whereas this is pretty much just one thing to do. This is a lot simpler to do your calculus with, so you'll appreciate this next year, I promise. 45 is a verify, and when you see verify, it's just this shy of a proof. So remember when we did proofs, you start with something and you prove what it has to equal. It's kind of like working an equation out. You don't know where it's going to go. So when it says verify, you're showing that this piece is equal to that, or you can start here and see if it equals that. But you just need to pick a side and pretend you don't know the other side exists yet, and then work until you find it. You can start either way you want. You'll start to kind of get a feel of which side's probably easier to start with, but if you don't know, that's part of the learning experience. Just pick one. And if you're hitting dead ends, try the other way. If you hit a dead end there, then just keep at it. It gets better, okay? That's part of the process too. You hitting dead ends and failing in math is just part of the process. It doesn't mean you don't know what you're doing. It's just that's how it goes. So from experience, I'm going to tell you that most people have more success starting on this side. So that means I'm going to start with log base 5, 1 over 250. and I'm going to say equals something, and I'm going to pretend that I have no clue what it equals, and I don't know what that's even there. So eventually I want to see that this ends up being that. But again, I'm going to start like it's just to solve this equation, and I don't know what's over there. So log base 5 of 1 over 250. Well, I don't know anything. I don't know of a power of 5 that I can't raise 5 to something to get 250. Not something easily. I mean, 5 squares is 25, 5 cubes is 125, 5 to the 4th is 625, pretty sure. But either way, I'm not getting 150. So, I need to kind of come up with something else, maybe another strategy. Now, I know that these are divided, so maybe log base 5 of 1 minus log base 5 of 250, maybe that'll get me somewhere. And when you see log base 5 of 1, really log base anything of 1, that's a significant thing you need to be looking out for. So let's talk about that, because that can make things a little simpler right off the bat here. So kind of off to the side, if you don't know what that is right away, that's all right. At this point, you're probably not very good at thinking in logs. If you are, great. It took me a long time to be able to think in logs. But eventually you're going to probably get there. Just with experience, you'll get there. But for now, if you can't really come up, if right off the top of your head you don't know what the log base 5 of 1 is, that's okay. Do this. Say, well, it equals something. And then rewrite it as an exponential, because you're going to be more familiar with exponentials at this stage. It's just the way you've worked with them more. So if you rewrite that, 5 to the n equals 1, and then you just solve it. This one's not too bad. What was the only thing n could be? What's the thing that if we raise anything to that power, we get 1? Well, n's got to be 0. So that tells me that the log base 5 of 1 is 0. It's got to be. So this part right here can just go away. That's 0. So I don't have to write that anymore. I'm not. I'm just going to go ahead and say, all right, negative log of base 5 of 250 over here. Okay. Well, I've still got that other problem I talked about. I don't really know a power of 5 that gives me 250. So let's maybe see if change of base is a way to go. Kind of like that first example we talked about today. So let's see, 250. Let's break it down. If you're going to do change of base, usually you want to break things into prime factors, see what you get. So 250, 25 and 10 will work. 10 is 5 times 2, 25 is a couple of 5s. So 250 is 5 cubed times 2. Okay. So let's see what that gets us. Let's rewrite it, log base 5 of 5 cubed times 2. Now both of those examples, both of the problems we went through already kind of lead us into some good stuff here. Because this is now 2 terms multiplied. And you got this negative out front. That can be kind of annoying. So what I'm going to do is say negative 1 times whatever I get. Because I don't want to deal with carrying this negative through. I'm just going to say negative 1 times whatever happens here. Okay, so log base 5 of 5 cubed. Now if these are multiplied, then the logs would get added. So log base 5 of 2. Let's stop there and make sure that makes sense. Again, the negative, I'm just going to call it negative 1 times all this stuff. So if these are multiplied, the logarithms get added together. That's how I got to here. So let's see what else we can conclude here. Well, that's log base 5 of 5 cubed. The 3 can come out front. That goes away. So that's going to be 3, just 3. And that's going to be, really can't do much more with that. There's really, if you tried that approach I did over here, and you say, all right, well, maybe this is something. Let's just see what it comes out to be. All right, well, 5 to the n equals 2. 5 to the first is 1. 5 to the first is 5. 5 squared is 25. 5 to 0 is 1. Somewhere between 0 and 1, but it's not going to be a nice number, so let's not take it any further. And I've got that negative out front. Let's apply that. So negative 3 minus log base 5 of 2. And I believe that's what it was supposed to equal in the first place. If it does, we are good to go. So that was a verification. We picked one side, worked it out until we got it to be the other side. These are they might be lengthy, and you'll get more efficient. The more of these you practice, the more quickly you'll get to the answer. You'll start to look for certain patterns and recognize shortcuts you can take, things like that. If you're If your work takes 20 steps right now, don't worry about it. It'll get better. Just go. Just jump in, do stuff, and just whittle it away. All right? Don't worry about efficiency yet. Now, by the test, we want to be efficient, but for now, just keep practicing that. All right, 61. Natural log, x squared minus 1 over x cubed. There's a little thing here that a lot of people mess up on. It's kind of easy to get it backwards. I'm going to clarify in a moment. And then you got your little wise guy thing over here. X is greater than 1. They give us that as sort of, well, by the way, make sure you fit this condition. You don't have to worry too much about this stuff. It's just there'll be a thing at the end where you could have said, oh, well, x is 0. We're done. There's no work that can be done. So they give these little things so if you're a wise guy, you can't claim those little caveats and be done without doing any work. If you don't know what I mean, don't worry about it. Just dive into the work here. We're supposed to expand this thing. So right off, I'm seeing that these two pieces are divided. So I want to rewrite this as the subtraction of two logarithms. Now, I'm gonna do this wrong. I'm doing it red. Here's the biggest mistake I see. All right, let's think about why that might happen. We've got x squared minus 1. Two things being subtracted. And then I'll see them all of a sudden written as log of x squared over 1. All right, so if I divide two numbers, their exponents would have been subtracted. Logarithms are exponents, so the logarithms would be subtracted. Doesn't work the other way. If I subtract two numbers, if I have x squared minus x, their exponents wouldn't do anything. Right? If I'm subtracting these two things, their exponents don't change. Let's make one have a, let's give them the same power and make one a little different. So that would be 2x squared. Okay, the exponents don't do anything there. They don't change. That means if you were subtracting two things in a logarithm, you don't change anything about the logarithms. There's nothing to change. So just be careful. This is a mistake I see a lot. It's kind of a one-directional thing. Just because these are subtracted doesn't mean you divide the logarithms. So the correct way to look at this, let's go back to, I usually use red when it's a mistake, so let's not do that. These two pieces are subtracted. So log x squared, I'm sorry. So these two pieces here are divided. So that means I can take log of this piece minus log of this piece. So log x squared minus 1 minus log x cubed. This one's sometimes kind of sneaky. Now x squared minus 1, that's a difference of squares. So that can be written or expanded x minus 1, x plus 1. We'll use some double parentheses there. Minus log x cubed. Now, if two terms are being multiplied, the individual logs could get added. So if numbers are multiplied, their exponents are added. Logarithms are exponents, so the logarithms add. So log x minus 1 plus log x plus 1. And I'm going to go ahead and take care of this step. This is log of x cubed, so the 3 can come out front. I believe that's all we can do. I don't see anything else to do. And back to that little wise guy thing at the beginning, where x has to be bigger than 1. So suppose x is exactly 1. Well, put it right here, and you're taking log of 0, which can't be done. Put it in right here, and it's log of 1, which is 0, and it cancels some things out. But mostly it's because it wouldn't work. If you put in 1 right here, this whole part's done. It can't be done. And it's really about the domain of the whole thing.